Hi, namaskara. Myself Mahesh Prasad from Department of Physics, as you know. So right now we are in a chapter that is motion in a plane, right? So under this particular chapter we are discussed a few things like a vector. Under a vector we have seen different types of vector, that is a unit vector, coplanar vector, concurrent vector, as well as a resultant vector. So these are the basic forms of vector we have seen so far, right? So now the thing is, the things which I have studied in the previous class, that is a general rule for vector addition, correct? So by taking help of that particular idea, today we will discuss one of the major topic, that is a triangle law of vector addition, which you can see on the board, that is this, the law which is given on the board. So before we get into this, let us have a quick review of a general rule for vector addition, okay? So let us take one example somewhat like this. See. So now, if I say this is one vector over here, and if I consider this is the tail of the vector and this is the head of the vector, now when you can add the two vector, in such a way that the head of the first vector should coincide with the tail of the second vector. And how we can take a resultant vector over here? How to take a resultant vector? I hope you got it. The resultant vector you can take in such a way that the tail of the first vector should join with the head of the last vector. Then only I can say there is a resultant which comes into the picture over here, somewhat like this. This is the resultant I can expect. And this is a rule which I have discussed in the previous class as well as, correct? So by taking the help of this, let us assume things that there is one vector which is there over here. Let us say it is the origin point O, and this is the point, I can say that is a P over here. And this OP is a vector that is called as A vector over here. A vector which is having a magnitude of OP, okay? Now at the mean point, at the mean time, the one more vector I can have, that is OQ with the vector that is a B vector. Now with the direction somewhat like this, do you think I can take a resultant vector from here to here? No. According to your general rule for vector addition, you are supposed to get a resultant from where? How to get a resultant vector? Resultant vector can be drawn only from tail of, if I say it is the first vector and it is the last vector or second vector, you can draw a resultant from where? Tail of the first vector to head of the second vector. So now the thing is, here also head is there, here also head is there. Can you get a resultant? You cannot get a resultant. But how to get a resultant? By the way, it is very simple. I shift, if I say it looks somewhat like this, and I shift this vector over here. I'll place it over here. So that what happens here? This is a vector OP with the vector A. If I place this vector over here, what happens? This vector comes into the picture, that is Q comes over here, correct? Now can I get the resultant vector over here? And here we have origin point or a tail of the first vector, and here we have a head of the second vector. So I can get the resultant vector somewhat like this. That is called as R vector. That is called as resultant vector, which is nothing but the value of a resultant vector, which is nothing but it is the sum of individual vector. That is the effective value for resultant vector, which is equal to the individual sum of these two vectors. So I can have that is R vector, which is equal to A vector plus B vector. And you might have surprised at how I can write directly like R vector, which is equal to A vector plus B vector. Is there any proof for this? Yes, there is a proof for this, that you are going to get under the will prove this the same concept with the analytical observation that you that in between the class I am going to explain that. and this proof we are going to expect under the concept of parallelogram of vector addition. Okay. So now according to your triangle law, what it says that if two vectors acting, which are the two vectors we have, there is a vector as well as a b vector. If two vectors are acting at a point b represented, both magnitude as well as the direction, and these two vectors are, don't you think these two vectors are having both vector as well as the magnitude, both the magnitude as well as the direction? Which is the magnitude we have? OP is the magnitude of what? Vector A, and OQ is the magnitude of what? Vector B, correct? And don't you think these vectors is having some direction? So this vector which is direction is in this direction, and OQ is having in this direction. So the direction as well as the magnitude we are not at all changing. Are you getting? If I place from here to here, do you think the directions will change over here? Never. So similarly, both magnitude as well as direction by the two sides of the triangle taken in the order. Don't you think these two vectors are taken in the order over here? Correct? No? See, if this is a head and this is a tail, and this is look somewhat like this, and this is the tail of the second vector and this is the head of the second vector, and if a tail of the second vector is coincide with the head of the first vector, I can say, don't you think this it is ordered in a proper order way from here to here, from here to here, correct? Now the thing is, how we have drawn a resultant vector over here, whether resultant vector we have taken in the order or not in opposite order. So can I say this is a resultant I have taken in this order. So that's what your triangle law says, where it is, see. Then this resultant which represent both magnitude as well as direction. Third side of the triangle. Don't you think this is a third side of the triangle? But it is in opposite order. And this is order from here to here is one order, and from here to here is a second order. But the third order we have taken it as opposite in direction. Actually it would be from here to here, but we have taken opposite order. That gives what? A resultant vector. So remember this particular point. Whenever we are taking a resultant, it should be opposite to the direction of a proper order in a particular direction over here. So hope this point is clear for you. So whenever we are taking a resultant vector, you supposed to go with the triangle of vector addition. That before that you supposed to keep that in your mind. Whenever we discuss about any vector addition, we supposed to keep in our mind that general law for vector addition. What is the general law for vector addition we can have over here? That is nothing but when you can add two vectors, if it is, this is a tail and this is a head, and this is a tail and this is a head, when I can have addition of two vector, if tail of the second vector, if it is coincide with the head of the first vector, then I can add this. Then how to take a resultant vector of any two vector? How to draw the resultant? You can draw a vector from where to where? From tail of the first vector to the head of the first vector in this direction. You cannot go in this direction, and it should go from here to here. And this gives what? The proof for your statement, which comes under the triangle law of vector addition. Okay. So next one we'll move on to, that is parallelogram of vector addition. Okay. Yeah. Fine. We'll move on to the one more topic, that is nothing but the parallelogram of vector addition. So by taking help of the triangle law, here in the triangle law obviously there are three sides should be there, but the thing is here we have a parallelogram means what? How many sides should be there? There are 4 sides should be there, in the sense, let us take initially the two vectors. Let us say the vector A somewhat like this, This is a vector A, and this is vector B. This is a vector A as well as vector B, which makes an angle theta with respect to at this particular point at the same time over here. Okay. Now, since we suppose to deal about parallelogram of vector addition, so what is the statement which says over here? If the two vectors are acting at a point can be represented both magnitude as well as direction at a direction by the adjacent side of the parallelogram drawn from a point. How to get adjacent side? Don't you think these are the adjacent sides over here? If I draw one adjacent side over here with respect to this, so this is A vector, the adjacent side of this is also A vector, which is having the same direction as well as the magnitude. Similarly, B vector is having the same magnitude. Let us say it is a point O, this is a point P, and this is a point Q, and this is a point S, and this is a direction, and this is a direction. Okay. So, what could be the resultant vector I can have over here? What is the resultant vector I can have? So, the resultant vector, according to the parallelogram of vector addition, the resultant gives the diagonal of the parallelogram. What is the diagonal of the parallelogram I can have over here? And this is the diagonal of the parallelogram, and this gives what? The R vector gives the resultant vector of the parallelogram, or resultant of the parallelogram gives, or diagonal of the parallelogram gives resultant of the vector. So this is how exactly it is over here. Now we have taken theta as angle between vector A as well as vector B over here. Now you are supposed to consider one point in such a way that is a Q, and you take one. This is a Q. This is a point where I can have a Q is a perpendicular. Let us say it is a point N, which is connected with respect to OP, which is produced. So let us draw one now. So draw QN perpendicular to, that is OP produced. OP which is produced over here. So what I can have over here? So by looking at the figure, what are the things we can confirm over here? That is, can I say that is OP, it is equal to A vector, correct? So similarly, OS, OP, and the OS which is equal to the OS which is equal to PQ. So the PQ is equal to, this is a B vector. What is the R vector we can have? This is R vector from O to Q we can have, that is OQ. That is OQ which is equal to the R vector. Then don't you think here also theta comes into the picture, because it is a similar angle which is there on the screen, on the board over here. So here theta comes into the picture over here. So can I say the triangle SOP, that is SOP which is equal to theta, as well as QPN, that is a QPN which is equal to what? That is a QPN, that is QPN which is equal to what? Theta you can have, because a similar angle will comes into the picture. So don't you think the right angle triangle Q and P is the right angle triangle over here, which is the extended one, right? So similarly, what I can have over here, you can take one triangle that is nothing but the Q and P, that is Q and P in a triangle, right angle triangle. By the way, you tell me, since theta which is there over here, I need a cos theta right now. What do you mean by cos theta? The cos theta which is nothing but what? If you have a right angle triangle somewhat like this, and this is nothing but opposite side, and this is the adjacent side, and this is the hypotenuse, right? So cos theta is equal to what? Adjacent by hypotenuse, adjacent divided by hypotenuse, correct? Now in the adjacent side, what we have over here? In the adjacent side, what we have? That is a PN. What is the hypotenuse we have? That is a PQ. So I need in a right angle triangle Q and P, I need what now? That is a cos theta. So the cos theta which is equal to, can I have that is a Pn divided by Pq over here. Or else with respect to Pn, what I can have over here? So PQ, what is PQ? We have P to Q. Don't you think it is the adjacent side of P over here? So this PQ can be rewritten as the B vector into the cos theta. This is one thing. How to get the sin theta now? Sin theta according to a general thing, sin theta which is nothing but opposite by hypotenuse. The sin theta is equal to opposite divided by hypotenuse. What is the opposite sides we have? This is the opposite side over here, that is Q1 divided by PQ, correct? So PQ is the hypotenuse. So can I have sin theta which is equal to, that is Qn, that is Q1 divided by PQ. That is the PQ which is equal to, right, with respect to Qn over here. So Qn which is equal to, what I can have over here? The Qn. The Qn which is equal to, once again, PQ which is nothing but what is the magnitude of PQ, that is the B vector. So the B vector which is into the sin theta, and this is how exactly it deals over here. Now you supposed to take in such a way that where I can utilize this particular Pn as well as Qn, so that you are supposed to take one right angle triangle, that is nothing but the right angle triangle, that is ONQ, that is a triangle that is ONQ, correct? So in a right angle triangle, ONQ or OQN doesn't matter, that is ONQ is a better choice. So in a right angle triangle ONQ, you apply your Pythagoras theorem. What it says, that is a hypotenuse which is equal, the hypotenuse square is equal to, in a triangle ONQ, that is can I have OQ square is equal to, that is ON square, that is ON square plus, that is QN square, correct? Now your ON can be written as what now? This is a ON, but we can rewritten as, that is OAP plus PN. So can I write this? So obviously we can write. So that is whatever this OQ we have, that is OQ. What we have? That is the resultant vector over here. So correct. So that is the resultant vector R square, which is equal to what we have. What I can write over here? That is OP plus, that is the Pn, the whole square, plus what I can have over here, that is the Qn. Qn can be replaced by what? The Qn can be replaced by, for time being you write the Qn, the whole square, that is R square which is equal to, your OP can be replaced by what? The OP can be replaced by A square plus Pn can be replaced by what? Your Pn can be replaced by B cos theta, that is a B cos theta plus the whole square. Now what we are having over here, that is OP is A, that is A, the whole square. Then Qn can be replaced by what over here? Qn can be replaced by B sin theta, the whole square. Now you apply your A plus B whole square. Don't you think this looks like A plus B whole square? What is the formula we have for A plus B whole square? That is nothing but A plus B whole square. We have A square plus B square plus 2AB. 2AB. So in the place of A, what we have? A. In the place of B, what we have? B cos theta, correct? So it looks like that is R square is equal to, that is A square plus 2AB cos theta plus B square cos square theta plus B square sin square theta. Now among these two, what I can take common over here? Among these, what I can take common? Obviously, B square is the common. What is there inside the bracket? Inside the bracket, we have R square, which is equal to, it it looks like a square plus b square plus 2ab cos theta plus this is sin square theta plus cos square theta. Altogether in the trigonometric functions we have that is sin square theta plus cos square theta which is equal to 1. And the sense here we have if I say here that is a plus b square is a common here. So sin square theta plus cos square theta is 1. 1 into anything is anything. So what is anything we have? That is the b square. So altogether we have that is r square is equal to a square plus b square plus 2ab cos theta. This is how exactly it looks. Or else we can have r is equal to square root of a square plus b square plus 2ab cos theta. This is how exactly we are supposed to write over here. Okay, and this is nothing but the magnitude or resultant. This is a resultant we can have over here. So this is how exactly we can have, and this is what we have found just now. It is the magnitude of r. If they ask in a question to find the magnitude, that is nothing but I can say this is to find magnitude of r vector. What is the magnitude of r vector? That is this. Now, how to get the direction of the particular vector over here? So, if I want to find the direction, of a vector, what I can have over here? What we can have? That is. So, how to get the direction of a vector r over here? So, if you want to find the direction of r, that is the direction of r vector. Now, you look into a same figure which is there on the board. How to get the direction? So, but you have to take one angle. Don't you think the direction of r, which makes an angle theta with the direction of vector r, vector a over here? So here, when beta will comes into the picture, the angle beta, this is a beta. So beta is the angle between the resultant vector r with respect to the direction of vector a, which makes an angle horizontally with the vector a over here. So that you take one triangle that is ONQ once again. So it's a triangle ONQ. What I can have over here in a triangle or right angle triangle ONQ. How to get tan beta now? Tan beta. That is a tan beta. The tan beta which is equal to what do you mean by tan function by the way? The tan theta which is nothing but the tan theta which is equal to opposite by adjacent. Opposite divided by adjacent, right? So that gives you a tan theta. What we have in the opposite side over here? Since angle comes over here, what is the opposite side we have? That is a Qn. So altogether I can have that is a Qn divided by what is the adjacent we have, that is On. But On can be split as what? That is OP plus Pn. So similarly, that is a Qn divided by what I can have, that is a OP plus Pn. But what we have for OP and what we have for Qn and what we have for Qn is everything is ready-made over here. We can go with the Qn as a b sin theta, and we can go with the OP as vector a, and we can go with the Pn as b cos theta. Now, how to do this? How to substitute over here? So the tan beta is equal to that is what Qn we have b sin theta. That is a b sin theta divided by OP we have vector a. So this is vector a plus that is a vector sin a vector. That is Pn can be written as P Pn can be written as B cos theta, and this is what exactly we can find, that is the tan beta over here. So this is called as the direction of a resultant vector over here. So how many equations we have got in today's class? That is one is the magnitude of r, that is r vector. R is equal to square root of a square plus b square plus 2ab cos theta, and direction of the vector r I can have, that is the tan theta, which is equal to b sin theta divided by a plus b cos theta. So this is what exactly we are supposed to find over here. Okay, and we'll see the special cases of this particular condition, that as I told in the beginning, we'll discuss about analytical observation of how we can write that r which is equal to a plus b, or r which is equal to square root of a square plus b square. All those things we'll get to know based on the angle of theta over here. Okay, yeah. Well, dear students, based on the topic which I have covered, that is r, the resultant, the magnitude of r as well as the direction of r. So based on this particular equations, we will try to solve a numerical, so that you are going to have the clear picture or clear idea about the particular concept, right? So once you have an eye on the numerical, which you can see on the board, that is there are two forces, that is 20 Newton as well as 5 Newton are acting at an angle 120 degree between these two vectors or these two forces. Find the resultant of its magnitude as well as the direction over here. Now here we have the formula to find the magnitude, and here we have a formula to find direction of the two vectors, right? So now what is the formula we have over here? That is r which is equal to, this is r which is equal to the square root of a square plus b square plus 2ab cos theta. Correct? No? Now in the place of a, what we have? In the place of a we have 20 Newton, in the place of b we have 5 Newton, in the place of theta what we have? It is 120 degree over here. Correct? Now r which is equal to square root of the 20 whole square plus 5 whole square plus 2 into 20 into 5 into, that is the cos theta, that is the cos 120. What is the value of cos 120? The cos 120 we have minus half. Okay, so altogether we have, that is nothing but that is a 400 plus 25 plus, here we have that is 40 into 5 into minus half over here. So altogether we are going to have r is equal to, that is 18 point, how much? That we are going to have, which is around 18.03 Newton. 03 Newton. This is the value of resultant we can have over here. Okay. Now what we are supposed to find its direction as well as along with the magnitude. This is the first case. The second case, we are supposed to find direction. So how to get direction over here? We have tan beta which is equal to what we have, that is b sin theta divided by a plus b cos theta. If it is so, in the place of beta what we have? We are supposed to find beta only. Beta gives direction. Okay. Now here they have got theta. Theta has 120 degree. Beta b has 5 and a has 20. You substitute. That is a tan beta which is equal to what I can have over here? Tan beta which is equal to, that is 5 into sin 120 divided by a, we have 20 plus 5 into cos 120. Altogether sin 120 we have, that is root 3 by 2, that is nothing but here I can have that is 5 into root 3 by 2 divided by 20 plus 5 into minus half. Altogether we are going to have tan beta which is equal to, that is around 0.2475, 0.2475, and this value gives tan beta value, but I need beta value. Now beta value is equal to the tan inverse of this value, that is at 0.24 into 75 over here. How to find this tan function? In a logarithm table, you have to go with the log table. Okay, for right now you can purchase one logarithm table. So in that you are supposed to check and for what angle gives this much value in a tan function table. You have to search where is 0.24, the corresponding angle as well as its meaning you are supposed to find. So if you do so, the beta value you are going to get 34 degree 54 minute you are going to get, and this is how exactly we can find its direction over here. Okay, so this is what we can expect under this particular topic, and in next class we are going to find the special cases of this resultant vector as well as the resultant vector of its magnitude as well as its direction over here. Okay, so keep that curiosity how we are going to solve that particular special cases, which is more important for your competitive exam as well as your board exam. Okay, so till that, see you, bye bye, take care.